Hello folks, we are once again back with this exercise 7.5 and it is the problem number 10 that we are going to take up next. We had seen till the problem number 9. Now let's look at the problem number 10. As such, it looks like there is a quadratic and a linear in the denominator, but the quadratic is of the type a squared minus b squared. So it can very well split in the form a minus b into a plus b, and that way we can get it simplified. So let's see how we can simplify this, and then we can check the partial fraction that we can apply over here. So let's consider this term and let's see how we can go about doing this. Consider 2x minus 3 over x squared minus 1 times 2x plus 3, which can happen to be 2x minus 3, a squared minus b squared. It splits as a minus b into a plus b. Now you can observe that the denominator are three linears. So, and we have learned that if it is three linears, it is a over the first one plus b over the second one and c over the third one. So it's as simple as that. So this is going to be equal to a over x minus 1, b over x plus 1 and c over 2x plus 3. It's very clear to us that this is the LCM. So let's try to change our fraction. This entire fraction has to be multiplied by x plus 1 times 2x plus 3. This entire fraction has to be multiplied by x minus 1 times 2x plus 3. This entire fraction has to be multiplied by x squared minus 1. That's what is going to happen. So you are going to get 2x minus 3 over x squared minus 1 times 2x plus 3 now will become a times x plus 1 times 2x plus 3, b times x minus 1 times 2x plus 3 and c times x squared minus 1 or x minus 1 times x plus 1, and denominator is going to be x minus 1 times x plus 1 or x squared minus 1 times 2x plus 3. That way both the denominators can cancel each other and therefore we are left with a times 2x plus 1 times 2x plus 3 plus b times x minus 1 times 2x plus 3 and c times x squared minus 1, which is equal to 2x minus 3. Now this is the place from where we are going to substitute and get the values of a, b and c, and that is how we are going to get the integral. So here it's very clear from here that we can substitute x as 1, you can substitute x as minus 1 and x as minus 3 over 2. So that way you'll get the answer. So let's substitute if x is negative 1. When x is negative 1, this a term will vanish and c term will vanish. The b term will be the surviving term. So that will become b times negative 2. So that's negative 1. So minus 2 plus 3. So that's 1. And on the other side, it is 2x minus 3. So I hope this is correct. 2x plus 3. So minus 2 plus, yeah. And this is negative 2, negative 3, negative 5. So b can become 5 over 2. So that will be the b value. So also let's take x as 1. When x is 1, b term and c term both will vanish, but a term will survive. So a times it's 1 plus 1, which is 2, and 2x plus 3, so that is 2 plus 3, which is 5. And on the other side, it is 2 minus 3, which is minus 1. So you get a as negative 1 over 10. So that is over. Now we can take x as negative 3 over 2. If x is negative 3 over 2, a won't survive, b won't survive, but c will survive. So you will have c, that will be 9 over 4 minus 1. And on the other side, it will be negative 3 over 2. So that is minus 3, minus 3, minus 6. So if we equalize this times 4, 9 minus 4, it's 5 over 4 and negative 6 here. So if you can take this on the other side, it will become minus 6, negative 6 times 4 over 5. So negative 24 over 5. This is a bit of a Herculean task. Once this is done, it's very easy. So now what happens to your I? Your I becomes integral 2x minus 3 over this whole thing has become this a stuff. So your a over, so a over means minus 1 over 10 over x minus 1 first. Next, b, which is 5 over 2. 5 over 2 over what's that, x plus 1. Then c, which is negative 24 over 5 over 2x plus 3. This is your integral. Now when we split this integral, it will become negative 1 over 10 can come here, integral of dx over x minus 1 first term. Second term 5 over 2 you can leave there, integral of dx over x plus 1. Next term, last term is negative 24 over 5 can come down, dx over 2x plus 3. Let's get the integrals. Very easy, they are all linears, so they are all going to be logs. So it's going to be log modulus x minus 1, then 5 over 2 log modulus x plus 1, and minus 24 over 5 log modulus 2x plus 3, but because there is 2x, that 2 can come here, and that way it will become 12 plus c. So you can just modify it and write minus 1 over 10 log modulus x minus 1 plus 5 over 2 log modulus x plus 1 minus 12 over 5 log modulus 2x plus 3 plus c. That's how the integral will work out. Let me just check the terms. Yes, so that's all for should be all for this, because it's quite a big problem. With the next problem, probably we can make it in the next video. Thank you.